Our research has three key objectives. First, we're developing a device to filter out harmful gases like carbon dioxide, carbon monoxide, and hydrocarbons from gas-powered vehicles. Also, we aim to reduce the amount of toxic emissions released into the environment, ultimately improving air quality. Lastly, we're working towards creating a device that's adaptable and compatible with various automobile models. Our goal is to provide a universal solution that can be easily implemented across different types of vehicles, thereby promoting widespread adoption and standardization in emission reduction efforts. Our research offers notable benefits. Firstly, by providing an eco-friendly option for gas-fueled automobiles, we're paving the way for cleaner transportation solutions that minimize environmental impact. Second, our device offers a cost-effective alternative for vehicle owners. By utilizing the natural properties of snail and mussel shells, we're able to create a filtration system that's not only effective but also affordable, making it accessible to a wider range of consumers. Most importantly, our research has the potential to significantly improve public health by reducing exposure to harmful air pollutants. By filtering out toxins like carbon dioxide, carbon monoxide, and hydrocarbons, our device helps to mitigate the adverse effects of air pollution, ultimately creating safer and healthier communities. With that, our group have decided to name our product GaMster, which stands for Gastropoda Mytilus Smoke Filter, wherein Gastropoda is the scientific name of snails and Mytilus is the scientific name of mussels. So for our product, of course we use snail shells, mussel shells, metal mesh to secure the shells inside, a wire cutter, safety gloves, food processor to grind the shells, and a 2.5-inch diameter exhaust tail end pipe wherein we will put the filter. For the first step of the product creation, we bought 1 kilogram of snail and mussel shells each. In this part, we are cleaning the snail and mussel shells. This is what the shells look like after cleaning and drying them up. In this part, we grounded the snail shells using a food processor. Also, the reason we chose to ground the snail shell first is because mussel shells are tougher and less brittle. As you can see here, we are carefully separating the larger shells from the smaller shells and then putting it back inside the food processor in order to gain consistency. To create the filters, 2.5-inch stainless steel metal mesh were measured with a length of 8 inches. The steel metal mesh is stitched into a cylinder with a diameter of 2.5 inch. Another steel metal mesh is stitched with a diameter of 1 inch, which then inserted into the larger cylinder. It is stitched together at the bottom and is filled with 150 grams of crushed mussel shells. Once it is filled, it is stitched at the top to prevent the shells from spilling. The filter was then inserted into the opening of an old muffler before tryout. The same procedures were then followed to create the other filter, which was out of snail shells. After creating the smoke filter, we will then proceed to the testing procedure. Via emission tests, 9 samples were collected by the Emission Testing Center. 3 trials were conducted per set of A, B, and C, focusing on the hydrocarbon, carbon monoxide, and carbon dioxide levels. The data from each sample were compared and used to determine the efficacy of the smoke filters in having the shells as its calcium carbonate supply, along with which type of shell was more efficient. With that, our product has been a success. Hydrocarbons were reduced by 8 to 23% from the setup without a filter. 33% was reduced from carbon monoxide despite only being present in all private gas-fueled vehicles. And lastly, carbon dioxide levels were lowered to approximately 17 to 91%. The emitted pollutants from the vehicle significantly decreased, which showcased the effectivity of the mussel and snail shells as a calcium carbonate supply in a smoke filter.